Hey everybody, in this video we are starting section 3 of chapter 1, and the name of this section is complex numbers. In this section, we are addressing complex numbers. Complex numbers bring together the world of real numbers and imaginary numbers. So that means we first need to introduce the imaginary unit I. And what is it? Where does it come from? So essentially, we cannot take a square root of a negative number. Why, you may ask? The reason we cannot take the square root of a negative number is because when you take a square root, you are finding what number times itself created that product. No number multiplied by itself will ever give you a negative answer, right? A negative times a negative is positive, and a positive times a positive is also positive. So how do you get a negative number uh, from squaring something? You just cannot. And square root is the inverse of squaring, right? It undoes squaring. So sure, maybe you just say, okay, no real solution, move on with our lives. But the reality is we build equations and work backwards from our answers and vice versa. So you can't just throw something away. You still have to classify it, identify it, name it, and give it a value so that when solving, we get that value, and then we can also work backward from that value in a nutshell. So what they did was whenever we have a negative value in our radical, a square root or even root really, but whenever you have a negative number under your square root, the part of it that is -1 is where our imaginary unit comes from. And we say it's not real, so we call it imaginary. And the imaginary unit is I for imaginary. Very creative, I know. So basically, I would imagine when I was younger that the negative comes out of the radical. It does like a backflip, bloop, 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 and it lands out front with so much Simone Biles gusto that a dot pops on top. Now, in this unit, you're going to use a lot of ones and I's for this type of stuff. It's very important that you make your one and your I clearly different. Really dot that I and maybe put like a hat and shoes on your one, some serifs or whatever you want to call them, right? So we got that. Okay. Now, here it says for all a greater than 0 right there. And then that means that it's -1 times a positive, which made it negative. Therefore, the rule would apply. I know it seems a little weird and backwards, but I swear it makes sense. So let's just do these 3 examples and see if you're getting the hang of it. So the square root of 16. Normally, the square root of 16, we would just put down that the answer is 4, but it's -16. The square root's already there, so the answer is 4i. That's it, done. Another way to look at it, if you use like a website of some sort to help you out, they might break it apart and show you that this is -1 times, the square root of -1 times the square root, times the square root of 16. And then this part is I, and that part is 4, and I times 4 gives you 4i. So you might see it broken down in different ways. And keep in mind that however much technology you may use to assist you along the way in checking your work and whatnot, don't count on that technology to do it for you, because you want to keep in mind that somebody programmed it to do that. And maybe one day you'll be a programmer doing things like that, but that means you have to know how to do it in order to program it. So yeah, let's not become a bunch of zombies that just copy things off the computer without thinking for ourselves, right? Use your brain. Can you do it? Do you understand it? Or are you just blindly copying, you know? Next example, -70. -70 as the radicand is not even partly a perfect square, right? 70 is not a perfect square. So what I like to do is make a prime factorization. Like 70 I know is 7 times 10. The I'm already taking that out. The 10, I can't even come up with anything good from there either, because, and this is all not necessary, but I'm still showing, 7 times 2 times 5. That's my prime factorization. It takes a pair to make a perfect square. Do I have any pairs that exist in the prime factorization of 70? No, I do not. Therefore, there's no perfect squares. If there's no pairs, that means it cannot simplify it. So I really just leave this answer as I root 70. So you could say this out loud a couple of different ways. I rad 70, I square root 70, um, I root 70, they all really mean the same thing. If it's a root other than a square root, you just need to indicate cube root, fourth root, whatever. But when it's a square root, that's the default. So final answer for those two, we are moving along. Let's get, highlighter. So final answer and final answer. Okay. Next one. This one we can simplify. So the negative still comes out and becomes I. 48. I'm going to pretend I don't know what perfect square is in there, but 48, if you are super desperate in breaking it down, it's even. So I'm going to start with 2. 2 times what? 24. 24 is 2 times what? 12. 12 is 2 times what? 6. 6 is 2 times what? 3. Double check it. Start with the non-twos. 3 times 2 is 6, 12, 24, 48. There you go. Now, many of you might already know that 48 is 16 times 3. If you don't know that 48 is 16 times 3, I suggest you put that one in your long-term memory. I think it's a good one to know, If you know 15 times 3, 15 minutes on a clock, when you have 3/4 of an hour, it's 45 minutes. And another 3 makes it 16 times 3. Whatever you have to do to remember this, I think it's very valuable to know that 16 times 3 is 48. Anyhow, it takes a pair to make a perfect square. So there's a pair of 2's and a pair of 2's. So 2 comes out for that, 2 comes out for that, because I really took the square root of 4 twice, or I can make it 4 times 4, square root of 16, whatever, but the 2 times 2 comes out. So my final answer is 4i root 3. And that is the final answer, 4i root 3. You should be simplifying your radicals very quickly at this point. If you have a negative on the inside, it comes on out. Does it get more complicated? Of course. This is example 1. It's pretty light. Don't forget that when the radical's already there, you just go with whatever sign's in front of it. These were all positive out front, so I just carried along with that. If you take a root yourself while solving a problem, please remember you are responsible for putting plus minus on your radical. Okay? Check the playlist for more videos. Maybe you'll find more of what you're looking for. Thumbs up if you got it good, and think this is going to be the easiest thing ever. Do it for the pug and the pumpkin. Thumbs down or questions, comments, concerns if you need to address anything in the comments. Okay? That's it for now. Sayonara. Adios.